Hi there. Welcome to today's episode of my 30-day journey on fractions, where I attempt to solve all fractions word problems that are essentially and specially selected from common entrance past questions, GSSE, SSE, and even SAT, which is Standard Aptitude Test. Now, before we delve into today's lesson, as usual, please be kind and generous enough to click on the subscription buttons below to get notified of more productive and educational lessons like this. See you in a bit. Okay, so today's questions are a set of questions on equivalent fraction. So let's see our first question for today. So we have x over 4 equals to 42 over 4. We are meant to find the unknown value, which is x. So to solve these questions, it's quite very easy and straightforward. We are going to be adopting a method called isolation and elimination method. So let's begin without wasting any more time. So I'm going to make an arrow as usual. Then I'm going to write x over 4 equals to 42 over 4. As I said, we are going to be using isolation and elimination method to find or to solve for x in these questions. What is isolation and elimination method? It's simply a method that allows you to eliminate a number so that we can isolate the unknown value. Mind you, our unknown value here is x. So we need to isolate x by eliminating the denominator here, which is 4. How do we go about that? Since 4 here is a denominator, so to isolate x and eliminate 4, which is the denominator, we simply multiply both sides, by this denominator, which is 4. Now, so to isolate x and eliminate 4, we multiply both sides of the equation by 4, which is the left hand side and the right hand side. So we are going to rewrite the equation to become x over 4, then multiply both sides, times 4 equals to 42 over 4 times 4. So how do we eliminate? 4 eliminate 4 here. Don't forget, 4 is a denominator here, and then the 4 we are multiplying it by, or we are eliminating it with, is a numerator. So 4 eliminate 4 here, and then 4 eliminate what? 4 here as well. Now in the numerator we are left with x, and certainly we have 1 here, we have 1 here, and we have 1 and 1 here. So in the numerator we have x times 1, and then in the right hand side of the equation we have 42 times 1. So we are going to rewrite the value we have left. X times 1 gives us x equals to, and 42 times 1 gives us what? 42. As simple as that. So our missing number, our unknown value, is 42. Let's move on to the second question for today. Now, second question for today is the same thing, or is the same thing as the first question. X over 5 equals to 27 over 45, which means that we are still adopting the same method. So we are still using our elimination and isolation, or our isolation and elimination method. So I'm going to rewrite the question as usual. X over 5 equals to 27 over 45. Now always take note, our unknown value is in numerator, then the number we are meant to eliminate is a denominator. So since it's a denominator, we are eliminating this value by multiplying both sides by the numerator of this same value. So we multiply both sides by 5. So I'm going to write x over 5 times 5, which is the numerator, equals to 27 over 45 times 5. Now this way we eliminate 5 by 5, and then we have 1, 1. And then 5 by 5 we have 1. 5 by 45 we have 9. Now if you look very well, you will see that we have 27 over 9, and 27 over 9 has a common factor, which means you can still simplify further. So we say 9 here 1, and then 9 in 27 we get what? 3. Now in the left hand side of the equation we have nothing more to simplify, so we just say x times 1, which gives us what? X equals to, which is this sign, then we have 3 in the numerator here times 1, which is 3. So x equals to 3 in this regard. You can see how simple and straight it is. Let's go on to the next question for today. Now, our third question for today, 21 over 24 equals to 7 over 8 equals to 49 over x. Mind you, I didn't explain what an equivalent fraction is. So, in simple language, equivalent fractions are fractions that are equal. They are equal because they have the same multiplier, and then they have the same what? Divisor. Or otherwise, you can say that an equivalent fractions are fractions that become equal when we multiply their numerator and denominator by the same number. That's an equivalent fraction. So finding unknown value in equivalent fraction is what this lesson is all about. So let's say the third question for today. In this regard, we have three series of fractions, this, and this. But then, how are we going to go about this? All along, we've been solving two fractions, two sets of fractions in the equivalent fraction. So what do? What we simply do is we will disregard this first one, and then we are going to pick this one and this one. That is this fraction that is next to the fraction that has an unknown value. So we are working by these two, and then we disregard this. So we apply, or we still use the same method, which is elimination and isolation method. So we have 7 over 8 equals to 49 over x. Now, our elimination method, if you look very well, you will see that unlike the first question and second question, our unknown value in this case is in the right hand side of the equation, and then our unknown value as well is a denominator. The first question and second question has the unknown value in the numerator, and then they also have it in the left hand side of the equation. So by this, we have the unknown value in the denominator, and then it's in the right hand side of the equation. How do we go about it? This is quite very simple. All we just need to consider is that the number we are eliminating, is it in the numerator or in the denominator? If it is in the numerator, we eliminate it by multiplying it by the same number, putting it in the denominator. And then if it is in the denominator, we eliminate it by multiplying it by the same number, but this time around we are making it a numerator. So to cut to the chase without confusing you, what do? We still multiply the same, we still multiply both sides of the equation by this number, but this time around it's going to be a denominator. So how do you do that? You just simply say 7 over 8. Instead of saying times 49, we want to get rid of 49, which is above x. Don't forget, that's the essence of elimination and isolation. We want to isolate x and eliminate 49. So instead of writing times 49 like we've been doing, or like we did in question 1 and question 2, instead we will write 1 over 49, because what we are eliminating is in the what? Numerator. So we make it a denominator. So 7 over 8 times 1 over 49 equals to 49 over x times 1 over 49. And in this case, or in this regard, it will be easy to eliminate 49 by 49, and then we have 1. And then here we look for what can divide. 7 can divide 49, and then we have 7 and 49 gives you 7, and then 7 is 7 in itself, we give you what? 1. So looking at the size of the equation, at the numerator here we have 1 times 1, then in the denominator we have 8 times 7. 1 times 1 will give us 1 over 8 times 7 will give us what? 56. That's for the left hand side of the equation. Then we put the equal sign. Then in the right hand side of the equation we have 1 times 1, and then we have x times 1. So 1 times 1 gives us 1 over x times 1 gives us what? X. Now, by this expression, or by this equation, we should know that our x equals to 56 and our 56 equals to x. But then we can't leave our answers like this. We have to isolate x and assign a value to it. We have to isolate x and assign a value to it. So how do we do this in this situation? Since there is nothing more to work on, what do? We just cross multiply. Crossing multiplying means we use this one to multiply this x, thereby bringing x to the left hand side of the equation, and then we use this 56 to multiply this, thereby bringing 56 to the right hand side of the equation. That way, we are going to make the equation to become literal, that is plain. So we are going to eliminate the fractions and making it a plain number. So 1 times x equals to this 1 times this x. That's what they mean by cross multiply. 1 times x, this is it here, then the equal sign is here, and 56 times 1, 56 times 1. So 1 times x will give us what? X equals to 56 times 1 will give us what? 56. Now we've isolated x, and then we've gotten a value for it, which is what? 56. So that's how we deal with such question. But then to consolidate this, let's move on to the next question that is akin to this one. Now, question number 4, 3 over 4 equals to 48 over x. So just the same thing as question number 3. Okay, so we go by the same method. The difference is that in the question number 3, we have we have 3 series of fractions, but in this case we have 2 series of fractions. But then we still have our missing numbers, our unknown value in the right hand side of the equation, and then we have our eliminating value at the numerator. So I'm going to make an arrow as usual. 3 over 4 equals to 48 over x. Going by the eliminating and isolating method, we want to isolate x. We want to isolate x in order to eliminate what? 48. Or we want to eliminate 48 in order to isolate what? X. Now taking note that 48 is at the numerator. That means to eliminate 48, we are going to make it a what? Denominator. So we are going to multiply both sides by 48, but making it or rationalizing it to be a what? Denominator. So I'm going to write 3 over 4 times, now times 48, but not 48, is going to be in the denominator. So 1 over 48 equals to 48 over x times 1 over 48. So we are multiplying both sides of the equation by 1 over 48 to eliminate 48. So now let's look for what can divide in the left hand side of the equation. 4 and 1, nothing can go. Then 3 and 48, something can definitely divide. So 3 in 3 we get 1, 3 in 48 we get 16. Now in the left hand side of the equation, there is nothing more to simplify. So we go to the right hand side of the equation. 48 crosses out 48, we get 1, 1. And we have 1 and x left. So we come back to the left hand side of the equation. 1 times 1, that gives us what? 1. Let me make a demarcation and make an arrow. So 1 times 1, that gives us 1. Then 4 times 16, that gives us 64. So we have 1 over 64 from the left hand side of the equation. Then the equal sign, I'm going to put it there. Then we have 1 times 1 in the numerator. We have 1 over, and we have x times 1 in the denominator. We have what? X. Now, in this regard, since we have 1, 1 in the numerator, to isolate x, what do? We cross multiply. Sorry, to neutralize the fraction and making it plain. To neutralize, let me use that word. To neutralize the fraction and making it plain, we are going to cross multiply. So I'm going to cross multiply. So x times 1 or 1 times x, that is going to give us x. 1 times x, that gives us what? X. Then 64 times 1, then I'm going to put the equal sign in between there. 64 times 1, that gives us what? 64. So we have neutralized this fraction, and then we've isolated x, and then the value for x is 64. So x is equals to 64. So the unknown value missing here is 64. So that is that about question number 4. Let's move on straight to question number 5. Okay, in this case of question number 4, we have the unknown value. The unknown value has a coefficient. A coefficient is the number or the value attached to an unknown value or to a letter. So this unknown value a has a coefficient which is 3, and that is what makes this question number 5 to be uniquely different from the other question. But then we are still adopting the same method, the elimination and then isolation, the elimination and isolation method to still solve this same question, the same way, the same process. Okay, so we go on, we're writing the question. 12 over 16 equals to 3a by over 20. Now, in our isolation and elimination method, what do we consider? We consider what we are eliminating and what we are isolating. We are isolating 3a in this regard, not just a anymore, because the a is attached to this 3. So we are isolating a and then we are eliminating 20. So if 20 is a denominator, that means to isolate a and eliminate 20, we are going to multiply both sides of the equation by 20, but at the numerator side. Okay, so that will be 12 over 16 times this 20. The 20 that we are eliminating is a denominator, so it's going to be a what? Numerator when we are multiplying it by both sides of the equation. So this is for the left hand side of the equation, and for the right hand side of the equation we are going to have 3a over 20 times 20. So now let's start from the left hand side of the equation. Let's look for what can divide. First of all, 12 and 16 has a common factor, which is 4. So 4 in 12 will give us 3, and then 4 in 16 will give us 4. Then 20 and 4 has a common factor, so which is 4 itself. 4 in 4, that will give us 1, and then 4 in 20, that will give us 5. Then let's move on to the right hand side of the equation, since we have nothing left in the denominator a except 1. So what can divide? Of course, 20 we eliminate what? 20, and then we have 1 and 1. So we have only 3a left in the numerator, and then in the denominator we are left with 1. So nothing more to do than to multiply the numerator by the numerator and then the denominator by the denominator. So that will mean that this numerator here times this 3 times 5. Okay, so I'm going to write that here. 3 times 5 in the left hand side of the equation, that will give us 15 equals to, then in the right hand side of the equation we will have 3a times 1. So 3a times 1 will give us what? 3a. Now this is a literal equation, a plain equation, which is 15 equals to 3a. Now what we are looking for is the value of a. So how do we separate this 3 from this a? What we simply do, since this is not a fraction, we adopt the same method of elimination. We are going to divide this time around and not multiply. We are going to divide both sides of the equation by the coefficient of a, which is 3, so that we can isolate a and then eliminate what? 3. Don't forget again, in fraction we multiply, but in plain numbers like this, whole numbers, we divide to eliminate. Okay, so we divide both sides of the equation by the coefficient of a, so that we can eliminate this coefficient and then isolate this a. So that will become 15 divided by 3, the left hand side of the equation, and then 3a divided by 3, which is the right hand side of the equation. So that way 3 we eliminate 3, and then 3 and 1, 3 and 15, we are going to get what? 5. So what do we have left? We have 5 in the left hand side of the equation equals to a in the right hand side of the equation. We've gotten our value. So that means 5 equals to a, or a equals to 5. We've gotten our value for a. So the missing number here is 5. So that is that for today's lesson. Thank you. See you in the next episode.